Hey, what's up? It's Jake from Nimbus DevOps, and I'm here today to talk to you about the property decorator. Another thing that would be a crime not to mention is the property decorator. So, imagine that you have an age attribute in a person class, okay? And at some point, you want to make sure that when you change its value, you're also checking that age is within the proper range, like 18 to 99. Well, you could write accessor methods such as get age or set age, which are also called getters and setters, by the way, and put the logic there. And then, like, get age would most likely just return age, while set age will set its value after checking the validity. The problem is that you may already have a lot of code accessing the age attribute directly, which means you're now up to some tedious code refactoring. And languages like Java overcome this problem by using the accessor pattern basically by default. Many Java IDEs, integrated development environments, autocomplete an attribute declaration by writing getter and setter methods subs for you just on the fly. So Python does this a little bit more elegantly, and it does this with a property decorator. So when you decorate a method with a property, you can use the name of the method as if it were a data attribute. And because of this, it's always best to refrain from putting logic that would take a while to complete in such methods because when you access them as attributes, you're not expecting to wait. So let's take a look at that example with a person. So let's make a class called person, and then we're going to find, initialize, and then do a self and an age, and then we'll say self.age is age. And don't use a capital L instead of a colon. There. Okay. So now I have a person. So now let's make another class called person with, not caps locks, class person with accessors. And we'll say define init self age and self.age equals age. But we're also, yeah, this autocomplete is not my friend. It's because I did that. There we go. Okay, and then we're going to define another one, and we'll say define get age, because we talked about get age, and that'll just be self. And all that's going to do is return self.age. Okay, and then we'll make a define, we will define a set age, which takes self and age. And we'll just do a quick quality check. We'll say if 18 less than equal to age, less than equal to 99, then self.age is age. Okay. And then we'll put an else clause in here too. We'll say else raise value error, and we'll just say age must be within 1899, like that. Okay, we are cooking with gas. So now let's make another class called person, and we'll do it in a more Pythonic way. And we can define initialize self age, and then in here, I'm just going to say self dot underscore age equals age. Self dot underscore age equals age. And then we use our property decorator. So we say at property define age self return self dot underscore age. And then I can use a setter by saying at age for the decorator dot setter, and then define age self age. And in here, we'll put our logic. So if 18 less than equal to age less than equal to 99, then self dot underscore age equals age. And if not, else raise value error. Raise value error. And then I'll just copy and paste this. Copy, pasta. Look at me copying and pasting things. I wouldn't keep this anyways. So I'm just showing you the different versions of this. So now that we've defined all this, we need to start calling something. So we'll say person is person Pythonic, and we'll say they're 39. And then we'll say we want to print person.age. Okay. And I'll put a note in here. You should get 39, and we are accessing as a data attribute. Okay. But then I could also say person.age equals 42, right? And that would give you 42. And if I said print person.age, you should also get 42. Um, but in this case, we say print. Let me get this right. So we set a person to 39, and then we print the age, and we should access that as a data attribute. And then when we say person.age is 42, you should get 42, but you're also going to be accessing it as a data attribute. I'll put that in the comment. So then we print person.age, you should get 42. And then, here, I'll just take this off. There, maybe that makes more sense. And then if I said person.age equals 100, you're going to get a value error, right? Because you're too old, right? So let's try that out. So Python property, and I see that no module name curses. Did I type curses somewhere? Line 13. Line 1 in module curses from import. Oh, because I auto-completed this on accident when I typed a capital L. Okay, save. Clear. Run it again. Okay, so we expected to get 39, which we did. We expected to get 42, which we did. And we expected to get a value error. And the value error said age must be within 18 and 99. And if I change this to 99, then what do you think will happen? Nothing. It doesn't do anything. Well, I mean, we don't get an error, but what I should do is I should print the person age, and you should get 99, and we can just verify that really quick, and we do. So the person class may be the first version we write, right? And then we realize we need to put the range block in place. So with any other language, you would have to rewrite person as person with accessor class and refactor all the code that was using person.age. So in Python, we rewrite person as person Pythonic, and normally you wouldn't change the name. So that age is stored in a private underscore age variable. And we define property getters and setters using the decoration that I used, and then that allows us to keep using the person instance as we were before. So I talked about getter and setter. So a getter is a method that is called when you access an attribute when you're reading something, so you're getting it, right? And a setter is a method that you call when you're accessing an attribute you want to write, because you're setting the value. So in other languages, like I've been using Java a lot as an example, it's customary to define them as like get age, set age, where you're doing like get underscore age, like as a function or a method or whatever. But in Python, the syntax is a lot neater, so it allows you to start writing a lot simpler code that you can refactor later on, but only when you need it. There's no need to pollute your code with accessors only because they're helpful like in the future. And the more you work with developers, and I have a friend who's very good at this, Jim. Jim, if you're watching, hey man, what's up? He's been doing this so long, he has this talent where he can kind of like look into the future and kind of guess very, very accurately what kind of issues this is going to cause in the future. And he does put things in the code to account for that, which is good. But it also, it's not necessary doing it this way because we don't need to code things that don't exist right now because we're making it easy to refactor later. So, um, in closing, I guess the property decorator allows for read-only data, not by writing the setter counterpart, but like for special actions when the attribute is deleted. So if you have any issues or want to know more about the details of setters and getters, especially setters, then take a look at the official documentation, because I'm not going to go any deeper than this here. So that's it. If you have any questions about property decorators, let me know. And if not, then happy coding.